Okay guys, I'm back and I am really excited because today I get to talk about my soapbox. So if I get really excited, just know that it's the scientific part of me that's really excited about viruses and my soapbox, not the human part of me that like weirdly loves coronavirus or something. I don't. So I was doing some domestic things today and I was using this, toxic chemicals. It was just a quick counter job, okay? So, I noticed that it said antibacterial. And I had this thought that I bet there are a lot of people out there right now that are like, ooh, antibacterial, that's exactly what I need to keep my family safe. But then my mind started going about my soapbox. So I have to share that antibacterial, although helpful, is not going to help you against the coronavirus. And here's why. Viruses and bacteria are not at all the same thing. In fact, bacteria are alive because, and I'm sorry, this is backwards, but just kind of imagine that it's not. To be alive, you have to have 7 different things. You have to have all of them. So this says you have to be able to grow, respond to your environment, be a cell, at least one of them, and you have to be able to have a metabolism and do homeostasis, which, like, look that up, or I can talk about it later. DNA or RNA, one of the two, you have to have it, and you have to be able to reproduce. Bacteria can do that. Viruses are tricky, and the reason that they're tricky is because they have a lot of these, like, sort of. So, they have DNA or RNA. Coronavirus is an RNA virus. They can't really do homeostasis, they can't metabolize, they're not a cell, they're covered in like a protein shell, but that's not the same thing as being a cell. They don't, I mean, they respond kind of, but not in the way that an alive thing would. They can't grow, and the one that I really want to talk about today is that they kind of sort of reproduce, but again, not the way that alive things should. They can't just take their DNA and give it to offspring. They have to use a host. This is where you come in. And this is where I get really geeky. Because viruses are so crazy genius. They are not alive. We've just discussed this. But just like a robot, this is what I tell students, they're like a robot, where you know it's not alive, but dang is it smart. So, this is DNA, and this is RNA. You'll notice this is only like a half of this. There's a few other differences, but for the purposes of this video, this is all you need to know. You're supposed to create traits in yourself. You're supposed to be able to go from DNA to RNA and then a protein and trait. But an RNA virus, called a retrovirus, is going to hijack your body. This is why they need you. So they can't kill you too fast because they need you. And so this is its RNA, the coronavirus RNA, for example. And it, instead of going this direction, is going to say, nope. They actually have a special ability where they can create DNA out of RNA. Oops, that was a issue. And then they're going to, they don't delete your DNA. This is just, they chop it and they scoot it out of the way. And then insert themselves right there into your DNA. So then, when you do your normal process of DNA to RNA to proteins to traits, there they are, along for the ride. It's just like a little fine print in one of the Congress's bills or something. It's a rider. So this is viral DNA that is now in your DNA, and actually scientists estimate that by the time you die, you're going to have about 8% of your DNA that is not yours, the viruses that at some point tagged along for the ride. Okay, that was just a fun fact. I think retroviruses are really cool. Now, back to the original point. Back to my original list here, I got a little bit erased. If these are the things that you need to live, and a virus doesn't have this one, doesn't have this one, doesn't have this one, doesn't have this one, has this one, and kind of has the reproduction because it uses a host, it's not really considered alive. So what that means is you can't kill it. Again, my analogy here would be like a robot or even a zombie. You can't kill something that was never alive. So when you use an antibacterial, good for you. You're killing bacteria. But it can't do anything to a virus. you need an antiviral, or you need something that's going to pop open its shell of sorts. Or in the case of the medicines that they're working on, they can't use an antibiotic. Antibiotics are my other soapbox. I'll come back to those later. But the thing that they would have to use is something that would either kill the virus enough in your body, kill the virus where it like pops open, or something that prevents this from being able to happen. This is how they treat HIV, and it's actually going really well, by the way. You should look into that. But this is how you have to work with a virus. It's not the same thing, and this is why when you go to the doctor and you have a cold or a flu, normally a good doctor would just say, sorry, there's nothing I can do. You gotta ride it out, because your body will eventually figure out how to fight it. Unlike strep, for example, which is a bacteria, and you can kill because it's alive.